Okay. Okay, we have done 2 quiz so far, and I already marked the quiz number 2, so you can go and see your answer in Moodle. So I already marked, so you can see what happened in your quiz number 2. I'll give you maybe one assignment. I'll give you one assignment to 1 or 2 assignment is 30%. Okay, and then one exam. Your exam will be on 13th of December. Okay. Okay. Today we're going to look at chapter 3, new chapter. We're going to look at differential equation. We're going to define the order, direct, integration, first order, then a few more strategy to solve a differential equation. All right. So I'll be using this book for this chapter. Okay. So the first thing is a definition of differential equation. What is the form? Oh, sorry, I forget to hide all this. But anyway, when you talk about differential equation, means you differentiate the equation. Right? Differential equation means you differentiate. You dy dx, ds dt, dA dt, and so on. So as long as you do differentiation, you are involved with differential equation. And by the highest derivative that you see in these 3 equations, you can categorize them into different names. Different name. So the first one, the first type of equation that you've seen so far, dy dx equal to something. The highest order, okay, the highest order that you see in the differential equation is 1, right? The highest order over here, d above here is 1, if you compare to the second equation. So d above here is 1, and dx x here also 1, if you compare to second equation, right? So if you see 1 and 1, it fall under first order differentiation, the differential equation. All right, nothing complex here, right? Look at the equation, you should guess what is the name of that equation, of that type of equation. So we already completed first order differential equation so far. Okay, for the previous chapter 2, chapter 1, chapter 2 so far, already done. First order differential equation. If you look at the second one, by using the understanding of first order differentiation, you look at the equation. This one is what? Nizam, you want to guess what is the name for this equation? What is the highest derivative you have here? The first one, the first equation here, we name as first order. The reason of first order because of d1 here and dx1 here. If you look at the second one, what do you guess? What will be the name of second equation here?
Second order.
Second order what?
Second order differentiation equation.
Differential equation. So again, if by looking at the form or the pattern of the equation, you know that you can categorize them into first order and second order. First order, you look at the form, the pattern. So this one, second order, because you look at the whole equation, the highest derivative. The higher derivatives means the one that beside the d, you can see in this one is 2, then it fall under second order differential equation. You need to check the whole equation. All right. Now what happened to third order? Third order means you change the 2 become 3. Okay. Now another one, you combine what you learned so far to this one. Okay. What do you think this one will be? Okay, I'll just give you the answer. Huh? So another one is called degree. Another one is called degree. Degree is the highest power in the equation. So if you combine the first one, second one, you look at the third one. The third one, Nizam, the third one is first order or second order? The third equation here, it is the first order or second order? If you look at the third equation. Nizam, this question for you.
Yeah, second order.
Second order, all right. Now, you combine the wording of degree and second order for this equation. How do you name it? This one, if you look at this equation, the name of this equation is second order differential equation of degree 3. Because if you look at the highest order you have, you look at on top of the degree is 3, right? So we call it degree 3. Why we do not look at 5? Because 5 here, you look inside this one is only first degree or second degree, this one. Edmund, this one is first degree or second degree?
First.
This one is first degree. Huh? So the name of the equation, we look at the highest order. In this equation, the highest order is 2, which is the one on the far left. Right, you have the d square there. And then look at the highest order. You look at what is the power above the, what is the degree above, or what is the power above the bracket? It's number 3. So the name of the third equation here is second order differential equation of degree 3 and not 5. Okay, huh? Edmund, pay attention to this one. Huh? Okay, I'm going to ask you a question, Edmund, later. Any questions so far, Edmund?
Yes, sir.
You okay, huh?
Yes, sir.
Okay, I'll highlight for you where to look for degree. Okay. Now, when we solve the first first order differential equation, we will look at first order. Next chapter, we look at second order, and following chapter, we look at second order and some degree, right? So this chapter, we look at first order differential equation, which is the simpler one. Okay, next chapter, we look at this one. We look at this one. Solution to solve this one. Okay, we write the question, dy dx equal to the function of y. We do it by differential. Right? How do you solve differential equation? You rearrange the equation. Y, you put y dy one side, or all the y at one side on the left normally. Then you pull the dx from the left to the right. When you see the linear equation of dy one side, dx one side, you know the next step will be integration. We keep repeating this in chapter 2. Okay, so from here, you get back the equation by using integration. How do you arrive at this one? By rearranging this equation, you pull the dx to the right. You are seeing dy equal to fx dx. When you're seeing dy one side, dx one side, you know that automatic the steps will be using integration. When you integrate dy, you get y. When you integrate fx, you get this one. Okay. I apologize for this one. I forget to hide this one. Example number 1. Okay, this one will be like a very, very simple chapter for you because we have repeated all this in chapter 2. So, determine general solution of x dy dx equal to minus 4x power 3. Again, just now, how do you solve differential equation? The steps is to chain differential using integration process. Okay, Edmund, how do you write this one in dy dx equation? Can you tell me the answer? How do you rearrange this equation into dy dx equal to what? Nizam check, Nizam and Shakir check the answer. All right. Edmund, what is the answer if you rewrite this one in dy dx? Dy dx equal to what? Those watching on YouTube, you can fast forward to the answer. Edmund, do you understand what I'm asking?
No, sir.
Do you understand this one is one equation, Edmund?
Yes, sir.
I'm asking you to rewrite this equation in terms of dy dx. I'm asking you, you are seeing this one as one equation, right? What
Yes,
is the answer of dy dx? Dy dx equal to what? Let's say you are given this equation. I ask you to rearrange this equation, dy dx, one side, what is on the right hand side of the equation? You understand what I'm asking, Edmund?
No, sir.
You understand this is one equation, right, Edmund?
Yes, it's a one equation.
You understand, right? This equation is x multiplied by dy dx equal to 2 minus 4x square, right?
Yes, sir.
How do you rewrite this equation? I only want to have dy dx on the left hand side, and what happened to the right hand side? If I don't want to see x in the equation, I only want to see dy dx on the left. How do you rewrite this equation? Edmund, this question for you.
2 integrate
What is your answer, Edmund? Repeat your answer.
2 bracket
2 bracket what?
4 multiply 3 s power 2.
Again, repeat your answer. dy dx equal to
2 bracket
2 bracket.
4 multiply 3.
How you get that? Nizam, can you what is your answer if you want to rewrite this equation in dy dx? What is your answer, Nizam?
2 minus 4x power of 3 over x.
Again, your answer? 2 minus 4x power 3
3 over x.
over x. Correct. Edmund, if you're not able to follow, I recommend you to drop this module and redo your next one. Huh? I only ask you to do a very simple mathematics here. I ask you to rearrange this equation in this form. You're not able to answer. Yeah, Edmund, this is my recommendation for you. I don't think you're ready for Max 2. Huh? Okay, so yeah. So what I'm asking is to ask you to rewrite this equation in dy dx. So what you do, you take x. This is a multiply. So what you do to remove x from the left-hand side, you just divide. From the left to right, you just divide. Okay. Then after that, you split them into 2. Okay, you split them into 2. The first part, you get 2 divided by x. The second one, minus 4x cubed divided by x. So you have dy dx, right? dy dx equal to this one minus this one. The next steps, to solve this one, we need to change this one into the integration steps. What do? We move the dx again. Once we export this x to the right hand side, we will export this one to the right hand side also, so that we can do integration. So you move your dx to the left, you add in the integration sign. Okay, so this is what you get from here. You want to integrate, right? So you integrate here, you move your dx to this one. Okay, you move your dx to the right hand side, you add in the integration sign on the left, and on the right, you will arrive at this one. Edmund, do you understand from here to here?
Okay, yes, sir.
Okay. Shakir, you okay? Yeah?
Okay, sir.
All right, good. Now, once you arrange your equation, this strategy for chapter 3 is quite easy. You always arrange your left-hand side equal to dy dx, and then you tidy up on the right-hand side. Then you move your dx to the right-hand side. You put in the integration sign both sides. You'll get integration equation. This one we keep repeating, give you a lot of example in chapter 2 already. You should be able to do this one. Okay, so I will go very fast for this example. You can do this one minus integration of this one. Okay, you get 2, you pull the 2 outside, 2 integration 1 over x dx minus 4, because why 4? Because 4 is a constant. I pull outside the integration, I get 2x dx squared. Now I think this one Nizam expert already. Nizam, what do you get from here? The first one, what do you get?
2 ln x.
Correct, 2 ln x. This one Nizam expert already. Then Shakir, what is this one? You integrate this one, what do you get?
X to the power 3 over
Then multiply by 4.
multiply by 4, yeah.
Okay, you get this one. And
Yeah.
why there's a c there? Because we don't have limit. Okay, we don't have limit at the moment. Later on, when you do deeper and deeper, then you will see number here. So when you solve question without the limit, remember to give me the C or anything lah. You can write A, you can write B, you can write C, right? As long as not Y and X or any unknown that in the question. You can use capital Z, capital P and A. But just for convenience, I'll use C to represent constant. This is how you solve differential equation. Okay. Edmund, you understand what I asked you just now? To rearrange this one in this form?
Yes, sir.
We look at example number 2. If you understand, I'm going to ask Edmund again. So you are given one differential equation, 5 dy dx plus 2x equal 3. But now you're given some boundary condition, y equal to this one, x equal to this one. So ask yourself, if you understand example 1, what is the first steps? Edmund, what is the first step when you solve differential equation? What do you do?
Put the 5 and the 2s to the behind.
Well, what is the first step? We always want to arrange the equation in what? On the left hand side, we see what?
dy dx.
That is the first steps. Okay, so again, remember, differential equation question is quite easy. First step always same. You rewrite the equation on, you know the equation have left side and right side. First step, write your equation on the left hand side, rearrange the equation, left hand side you see only dy dx. Edmund, what is the equation of dy dx equal to what? When you rearrange this equation, what is the first step you will see? Dy dx equal to what, Edmund? Solve this question. Nizam and Shakir, you prepared the answer. Okay, Edmund, answer this one. Dy dx equal to what?
Negative 2s plus 3.
5 negative 2x plus 3. How you get it?
I put the 5 and 2s to the 3 there, to the right hand side.
You put this one to the right, right?
Yes.
What do you get? 3 what?
3 over 2s.
You pull this one. What is this one? This one is 2x. You pull this one to the right hand side. What do you get? You move this one to the from the left to right. What do you get over here? Edmund, if you cannot answer this one, you have to drop this module this semester. I cannot allow you to continue because this is a too simple mathematics you cannot do. I don't want you to waste your time. You move positive 2x from the left. What do you get here, Edmund?
Negative 2s.
So 3 negative 2x. You left out this one. What is the relationship between 5 and dy dx? Addition, multiplication, division, subtraction. What is the relationship between these two? So when you move the 5 from the left to the right, what do you do? Edmund? What do you do with the 5 if you move from the left to the right hand side of the equation?
Uh, 2s body 2s 3 minus 2s over 5.
Okay, so that is dy dx. So this is the question given. First steps to solve differential equation, always confirm that you get dy dx at the left hand side. So you move whatever that is not dy dx to the right hand side. Okay, from here to here. Edmund, again, this is my reminder. If you cannot do this one to this one, please retake mathematics 1. I cannot allow you to proceed into mathematics 2. You're going to slow us down. Okay? I give you chance to show. By this week, if you're still not able to do the simple arrangement, I cannot take you as my student for this semester. Means you are not ready for next week. Okay, so we are arranging this one to this one. So make sure first step you get dy dx equal to something. Next, you break this one into 2. You break this one into 2. You integrate. So you dx pull to one side. Okay, dy equal to this whole thing, dx, and then you put in the integration. After you get dy dx, next step is to do integration. Okay, this one you break into this one, you get minus 2 divided by 5x plus 3 divided by 5. You should be able to understand from here to here. Next steps, pull your dx to the right, because the next step you want to do is integration. You pull your dx to the right hand side, you put in the integration sign. So on the right hand side you get y equal integration dx, put in the arrangement just now, negative 2 divided by 5x plus 3 divided by 5. Just a reminder to always check your answer, because I found that in this class you will always forget your negative. So if you see negative, remember to pull them along to the next steps. This one you practice quite a long of time. So you pull your 2 over 5 in front of the integration because it's constant value, x dx plus integration of 2 over 5 dx. Of course, this is a constant value, right? So you know constant value. Edmund, what do you get from this integration? You integrate x dx, what do you get? Edmund?
Yes, sir.
What do you get? Integrate x dx, what do you get? Shakir, what is the answer for integration of x dx? Shakir? No, you don't need to give me that. I just only ask what is the result of this one. What is the integrate x dx?
X to the power of 2 over 2.
Okay, correct. So integration of x dx, how you get x power 2? Because your x power n is 1, so 1 plus 1 divided by the new index here. So x power 1, you integrate, you plus 1 become 2 divided by 2. Okay, so this one you will get another x here because it's a full number. You integrate, you just add x there. So from here, you get this one, and this one, you get this one plus c. Nizam, you okay so far? From here to here, you're able to follow, Shakir? Sorry, Nizam?
Yeah, okay.
Okay. Edmund, you need to do your homework.
Yes, sir.
It's a very simple integration here, and we already done a lot of exercise on this one. Okay. Next, you just simplify, cancel the 2, or you can just remove the 2. This is the answer. Okay, this is the answer that we're looking for from the integration for the first part. Okay, for first part got c. Why got c? Because you don't have limit here. Now, what does what you need to do when you see the question give you boundary condition? It means give you 2 points, y and x. Now, the purpose of y and x value is to find what is your c. Again, I repeat, if the question so kind to give you the y value, x value, there's only one purpose. The purpose is to solve c value. You use the y value, you substitute inside here. You x value, substitute inside here. Here, there's only one unknown. You get your c. After you get your c, you substitute back, you get the full mark of the answer. So when you're given y and x, again, when you're given y and x, the only purpose we give you y and x is to solve c. So when here, you use your calculator. Okay, when you use calculator, you substitute your y, substitute your x. 1 and 2 over 5. You need to rearrange this one, get in the fraction, in the full fraction number. So this one is 7 over 5, right? 1 and 2 over 5 is 7 over 5. Edmund, do you get that one? Do you understand when I say 1, 2 over 5 equal to 7 over 5?
Yes, sir.
Okay. You substitute. For this example, I give you the detailed steps. Further example, I will just straight away give you C, and treat that as your homework. But in the exam or test, you need to show me these steps. Okay. So you substitute your y value given x here, okay, and just be careful in your test or exam when you substitute when there's a 2, continue to use 2. I've seen in your quiz, our class have someone who will forget this one. So you substitute only one unknown there, c will be 1. So once you get your c1, substitute here, you write the answer in your answer sheet. This will give you full mark after you solve what is C. Again, how you know we want you to solve C when you give you the y and x value. Or if you're integrating something equation, we give you the 2 number or two parameter that you can substitute inside. Then you are going to solve C. That is the purpose of boundary condition. Okay? Just take note of that. This is the hidden tips that we help you. When you give this one, means we want you to find C. Okay, let's do one more example. Solve this one. You are given the equation t bracket t minus d theta over t equal 5. Given theta and t. You know what is the purpose of this one. When you're given 2 number, this is to solve the C value just now. Again, this question changed the y and x, but only 2 unknown here. Shakir, what is the first steps? No, I don't want to ask Shakir. Edmund, what is the first steps in differential equation? What do you do?
dy dx.
You keep the dy dx on the left. But this one, what is your dy dx?
D theta over dt.
So you rewrite this one in d theta over t on the left hand side. Give me, Edmund, what is the answer for d theta dt equal what?
Sorry, sir.
Give me the answer. You know that the first step you need to write d theta dt, right? Give me the answer, d theta dt equal what? Give me the full answer. Rearrange this equation. Nizam and Shakir, you can sketch by the side just to double check Edmund answer. What is d over dt equal to, Edmund? I'll give you maybe 20 seconds to solve. Again, those watching on YouTube, you can fast forward until I show the next slides. Edmund, what is your answer?
Minus 2t plus 5.
Again, repeat your answer, Edmund.
D
theta dt equal what?
Minus 2t plus 5 over t.
Nizam, what is your answer? d theta dt equal what? What is your answer?
5 minus 2t square over negative 2t.
Rearrange. You move the 2t to the right hand side. Again, 2t and the bracket is multiply. You move to the right hand side is division. And then you move the negative sign to one side, and then you move to another side. Okay. This is when you arrange, you get from left hand side to right hand side. You move the 2t to the right hand side, 5 divided by 2t. Remove the bracket. You see t minus dv dt. Okay, you remove the bracket. You move negative to right hand side. You get positive. You move this one from right hand side to left hand side, you get negative. This is the answer I'm looking for. dt equal to t minus 5 divided by 2t.
Sir, I cannot do like this. Is it? The bracket inside one, 2t I times with that first and then I bring it out. Cannot, is it?
Again, your question is you bring the
The first question, right? 2t bracket t minus d theta over dt, right?
Okay.
What I did was 2t I minus with t, and then 2t I mean like 2t times with t, and then I times 2t again.
Okay. Means you break into you break into 2. You can do that. You can do that, no problem. But you can still simplify after you. You can still simplify to this. You still arrive at this one when you simplify. Yeah, no problem. This will be the one I'm looking for when you come to test exam. All right. As long as you show me the first step is to do the dy dx or d theta dx or something dp dq or something. On one side, then equal to something. Then as long as you put in this form, then you're showing that okay, you understand what need to do for the first steps. Okay. Yeah. Again, during exam test or equation will be different, but you remember the first steps. You need to put dy dx into one side of the equation. Normally in the left lah. So I just rewrite the one that we want on the left hand side, and then the rest you put on the right hand side. Now, once you get this equation, what you do, next step, you want to do integration. How do you do integration? You move your dt, move to right hand side. Then you are seeing the theta one side, dt one side. Okay. Now, when you do the integration, make sure, later we'll look at more complex equation. Make sure that one side is same thing. For example, this one, d theta. If you have d theta, you put all the d theta one side. If you have dt, then put all the dt at one side. That is the main objective. After you get the theta dt, that is the main objective. You check your answer, whether you have put the thing one side and one side or not. Okay. So if you are seeing the theta on one side, you still need to go and continue with the arrangement. Make sure the same thing on one side, the same thing on one side. So if you see theta here, you still not complete. You need to move the theta to one side. Okay, that is a reminder lah. Okay, next you do integration both sides. This one you move to the left hand side, you will get dt one side and bracket t minus 5 divided by 2t bracket dt. So again, after this, you just add in the integration symbol. you integrate t and integrate minus 5 divided by 2t. You can do simple equation. So this one, you know that this one is 1, right? Although there's nothing there, but you know that here is 1. Okay? In front of the theta is 1. Huh? In front here is 1. Huh? So integrate 1, you get theta. Then this one is 2 integration, t and this one. Okay, I didn't continue. Okay, example 3, I think I deleted one of the slides there. So although I'm not showing the final answer, what is the next step is that after you get theta, this one you'll get t squared divided by 2. When you integrate this one, t squared divided by 2 minus 5 over 2, you pull to one side, you get 1 over t, and you know that when you integrate 1 over something, 1 over x or 1 over p or 1 over t, you get ln. Okay, this one Nizam expert already. So once you get that one, you will get plus c. Okay, you will get plus c. You substitute your theta and t in the equation, you get the c, substitute back. Okay, so yeah, apologize for these slides. I think I accidentally deleted the slides, but the procedure still same like example number 2. Okay, once you substitute your x and y, you get your c, then you substitute back to this one, give the final answer. Okay, so this one I do not show you the complex steps, but the same procedure happen. Okay, so this one treat as your homework. To your homework to practice this one. I'll give you one more example. Okay, now this one you will see this one in your static and dynamic static class or material analysis module. So you're given one statement, but however you're still seeing the differential first order differentiation. So you're still seeing dy dx pattern, but in this case you see m and x. So you are giving a bending moment m given by one equation, and this one is the differential equation that you're familiar with. All right. So in this one, it straight away give you the equation, so you don't need to rearrange it. Where w and x is a constant, determine m in terms of x given m and x is given. So m equal to this one, x equal to this one. Again, when you look at a question, when you're given two value, again, the purpose is to find the c, in the integration. Okay, I repeat this one more time. In the question, if you're given two value for the unknown, you are given the y equal to what, x equal to what, or m. In this example, you only have m and x, so you're given the m and x. The purpose is to find the constant value when you come into integration. So the first steps to solve differential is to arrange your equation in dy dx. So in this case, you don't need to arrange, straight away you can use. Next step is to do the integration. How to start the integration? You move the bottom one, dx, move from the left to right. Then you add in the integration sign. Move this one to this one. So, of course, you need to expand the equation. So you expand minus WL minus, you get positive. Right? Just reminder, someone in this class always, when you see negative, he will give me another wrong number. Be careful on the positive negative side. Okay, so from here you open the bracket, you multiply, you get this one. Next you move the x to the right hand side. Okay, you move your dx to the right hand side, you put in bracket, or you can put dx here, same. I would like to put in bracket dx. When you see dm dx, you know next step is integration. So you put in integration, both sides. This one, you know, you'll get m. This one, you'll differentiate with dx, right? Nizam, what do you get from the first integration here? You integrate this one over dx, not over lah, but you integrate minus WL dx, what do you get? Nizam, are you there?
Yeah, yeah.
Yeah. You know that this one you can break into two integration, right? So I want you to solve the first one. You integrate negative WL dx, what do you get?
WL square over 2.
Is there any x there?
No.
WL, WL is you treat as a constant value. So what do you get? If this one is constant value, what do you get if you integrate?
Constant value.
If you get 1, integrate 1, what do you get?
Integrate 1.
You integrate 1. Huh?
Integrate 1, is it?
Yes, integrate 1 dx, what do you get?
1 over 2 by 2.
No,
1 over 2.
If you integrate a full value, individual value, what do you get? I'm not asking you differentiation, I'm asking you integration.
Half.
Shakir, what do you think? If you integrate 1 dx, what do you get?
X, sir.
Correct. The answer is x, Nizam.
Okay.
You integrate one full number, you just add the x, right?
Yeah.
So back to here. What do you get if you integrate minus WL dx? Nizam?
X. Negative x.
Negative x what? This is a constant value. You just continue to use this one.
Negative xl, is it?
No, WL is a constant number, right? Why you want to break the number? You see this one as full number. You will get WLX, right?
WLX, okay.
WL is a multiplication, right? So let's say you take 4 multiplied by 5, you get 20, right? Why you want to break into 2 and 0?
Oh.
You straight away to get,
I confused because it's not x.
Yeah, there's no x. Yeah, there's no x there, right? When there's no x there, it's a constant value. You can assume that as 1. You can look this one as 100 or 500 or maybe 10 or any full number that you like. So when you integrate a full number, you get x, right?
Yeah.
Let's say you integrate 4. What do you get? 4x, right?
4x.
So let's say WL is a 4. So you integrate this one, what you get? You get 4x, right?
Yeah.
So you see this one as full number. WL, you continue to write. Continue to write. The answer is WLX. Do you understand the concept? So because this one is a full number, no matter how you multiply, you still get a full number. You still get a constant number. Okay, now this one. You have a constant number multiplied by x. Integrate. You only focus on x. If there is no x, you add x. If there is an x, you just continue with the normal integration. So x square divided by 2, right? So just remember, I mean, this one maybe you guys forget lah, but try to recall back the integrations procedure. This one is just to open up your mind. Actually, sometimes you don't see x means you assume as a constant value. Okay, so from here you get this one. This one you get this one. Again, you don't have limit. That's why there's a c there. How to solve c? Because of m and x given. There's a purpose why the question gives you the value this one when this one. So what you do inside this equation, you are given the m, you're given the x. What is your c? Okay. Shakil, can you try to solve this question? Can you try to solve what is c by substituting m and x?
1/2 WL square equals to negative WL 0 plus W0 to the power of 2/2 plus C.
So what is your c?
So the first one and second one of course 0.
0,
So
0.
C, that one 0, that one 0. So C is directly equal to 1/2 WL squared.
Correct. So this basically quite direct because x equal to 0. So 0, 0, your c equal to m. Look at the question, m equal to this one. So after that, you get your c. Remember to substitute back to the equation. Okay. If this also have mark, but you do not continue, then you lose the marks behind this one. Okay. There's a purpose when we give you numbers in the question. When you give you x equal y, all right, x equal something when y equal to something, or x equal to something when y equal to something. There's a purpose when you give you this one and this one. This is to solve the c. So when you solve that one, you get your c equal to that one. Pull the c back to here, you get the full answer. Okay. Oops. So this is your full answer. Okay. All right. What else? Okay. The next, this is the answer. The next one will be, you can see here, I forget to put in the translation. I just rearrange this one. I rearrange this equation into a more simpler form through all these steps. This is what we get just now when we substitute the c. So I factor out the w. I factor out the w. I put in bracket. Then I slowly to see whether I can pull anything out or not. So in this case, I pull my half out. So when I pull my half out, I have a 2 here. This one I add in 2. Okay, I get in this one. So then I rearrange. This one actually is a quadratic equation. So I pull my x to the front. I rearrange this one. And I pull my this one. So this actually is a quadratic equation. So quadratic equation, you know that you can completing the square. So this one, put in this one. So how do you know the exam need to answer in what kind of form? In exam, if you give me this one, I will still give you correct. If the question continue to say, put your answer in the simplest form. If you see this statement, put your answer in simplest form, means you need to factor. You need to put in this form and not this form. Again, I repeat, if you see the question like this, you can put your answer like this. But if the question add one more statement in the question, put your answer in the simplest form. You see that statement in the question. Put your answer in the simplest form. Or maybe I help you. I add in one more sentence. Maybe you need to use completing the square. But normally I won't add that one. But normally you'll see, put your answer in the simplest form means you need to further process your final answer into the simplest form like this. Okay, so this from here to here actually is what you learn in your max one, where you need to completing the square. Okay, in the simplest form is this one. Okay. We will have a short break. End the recording.